Welcome. Today we are diving into the architecture of Redis, which stands for Remote Dictionary Server. It's an in-memory data structure store. This is a case study to help you understand its design and capabilities. So, what exactly is Redis? Redis is an open-source in-memory data structure store. It's used as a database, a cache, and even a message broker. Because it operates in memory, Redis offers exceptionally high performance, providing sub-millisecond response times. Additionally, Redis is versatile, supporting various data types such as strings, lists, sets, hashes, and streams, making it suitable for a wide range of applications. Let's explore the core architecture of Redis. At the highest level, client applications interact with the Redis server, which then stores data in memory. The Redis server utilizes a single-threaded event loop, which enables high concurrency. It efficiently manages memory allocation and optimizes data structures, ensuring quick data access and minimal overhead. Redis supports a variety of data structures. Strings are binary safe key-value pairs. Lists are ordered collections of strings. Sets store unordered unique elements. Hashes contain collections of field value pairs. Here are some basic operations. To set a string, use the set command. To get a string, use the get command. For list operations, push adds an element to the left side, and RPOP removes an element from the right side. HSET is used to set a field value pair in a hash. Efficient memory management is critical for Redis. Memory is allocated for active data structures, keys with time to live, also known as expiry, and available or free memory. Redis employs strategies like least recently used, or LRU eviction, which removes the least recently used keys when the memory limit is reached. Redis also has time to live management, where keys expire automatically based on their time to live settings. Redis provides persistence options to prevent data loss. The first method is RDB snapshots, which take point-in-time snapshots of the entire dataset. This method is compact and allows for fast recovery. The second method is Append Only File, also known as AOF, which logs every write operation. This provides better durability and minimal data loss. Comparing the two, RDB offers high performance in small file sizes, but AOF provides moderate performance with larger files. Recovery is faster with RDB and slower with AOF. Redis supports replication and clustering for improved reliability and scalability. In a master replica setup, data is replicated from a master node to multiple replica nodes. For clustering, Redis uses data sharding, distributing data across multiple nodes using hash slots. This setup provides high availability through automatic failover and fault tolerance mechanisms. Redis is used in many applications, including caching for high-speed data retrieval, real-time chat for message queuing and pub/sub, session stores for user session management, and analytics for real-time data processing. In summary, Redis offers ultra-fast in-memory performance, supports rich data structures, provides flexible persistence options, and has horizontal scaling capabilities. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.